Are we
I
going to
don't
see
have
any
the
cats flying across the room?
no, not yet. I do have a I don't have the multimeters hooked up at the moment, but I will hook them up, eventually as I get more set up here. But it is running. I have as you can see, I have the new. It's the same exact AK-45 stereo amp receiver, but I got the new one today, so it does work. I just tested it out. The reference circuit and the coil circuit. So this is the reference circuit. This circuit is not connected to the coil at all, right? The coil's not even plugged in right now, but so the reference circuit goes into the left channel. It's kind of hard to see, but here, let me see if I can. So in the back here, we have left and right channel. The lighting is bad. I'm going to get a flashlight. Can I turn on the flashlight on the phone? I might be able to turn my flashlight on the phone. There we go. Oh, it doesn't work. Anyways, so it's hard to see, but there's two speaker wires sets going out of one of the left channel and one of the right channel. The left channel is hooked up to the reference circuit here, and that's not connected to the coil. And then the right channel has the coil, and then the coil's output to this circuit. Same exact circuit. It's got a rectifier with 3 diodes and a capacitor. And then over here, it's hard to see, but you'll see when I light it up. It's got 3 LEDs and a 2K ohm resistor. Same circuit, same components. Basic Arduino kit components. And you'll see in a minute when I power up the stereo amp receiver and I put a specific frequency in, say 60 hertz, what we get out of the wall, the reference circuit will start spinning at a certain power, right? You can power it up a little bit by using the gain. And you'll notice that this is spinning, but this isn't on the output, right? Because you're getting a little loss or whatever. But when you resonate the load at around 800 hertz, it flips. And this starts chugging along or stops altogether. The lights are really dim, and this is bright as heck. And then the multimeter reading confirms that it's doubling the voltage while maintaining the current. So give me a second, I'll plug that in. All right, so the black and the red wires are the input. That's channel A of the rodent coil. The yellow and the green is the output. That's channel B. Channel A and channel B are in the same bundle of wire, but they're not connected. So we have 12 wires in series, well, technically 11 wires in series for each channel, and totaling 22 wires in the total in the bundle. But the 2 channels aren't directly connected. So the input is hooked up to the right channel of the stereo amp receiver, and then we're hooking up the output to this little circuit. Remember, the reference circuit is getting the same amount of power, but it's not hooked up to the coil at all. Right?
So you're showing us the difference of power from 2 circuits and how much the coil is going to be generating on its.
Yes. It's a visual, like it's an over unity visual. It's a way for you to visualize what exactly is happening when the system is in resonance versus what we get out of the wall at like 60 hertz.
Okay.
Gotta hook up the laptop real quick. The laptop is gonna be my tone generator. All right, as you can see, or if you can't see, let me know. But it's 60. I have the tone generator set to 60 hertz sine wave. We're going to turn on the stereo amp receiver, and we're going to notice that the reference circuit at a certain power level, we're going to slowly increase it, obviously. We're not going to pull it full power right away. And then we're going to notice that the reference circuit is going to power on while the circuit connected to the coil doesn't. So you see that?
Yep. Left side.
Yeah, I see the lights. Yep.
So, yep, this is spinning. Lights are on. We don't have any spin or lights on. And now I'm going to switch it to around 800 hertz and show you what happens. I'm going to set this down real quick. Bear with the camera. 800. Oh. So we have a problem with the coil. Give me 1 second. I need to check my connections. I don't think the coil is connected right. It might be a loose connection.
Yeah, it happens sometimes. When you're trying to do a demo and it doesn't want to work.
Yeah, it's just sometimes the wires come loose. Like, I pulled the stereo amp out to show you guys the back, but it might have come something come loose or whatever. I'll check real quick.
Look at that $10 pulse width modulator link I sent you, Ben.
Yes, I have that coming tomorrow along with the timing control circuit that Nathan recommended. So we'll get into that at some point this weekend.
I looked at the specs of those things. That's a good deal, man. Good deal for what it does. Being 150 watts also, I hope there's still $10 when I go to put my lab together because I want to get one or two of those things.
So I see that you did a good job of wiring that Rodin coil. I talked with Rodin. I met him at a conference. And he said a lot of people put bends in them, and you got everything nicely smoothly running around
Oh,
there.
not everything is smooth. There's a couple of bends in there, but yeah, the new one will be completely smooth. I did manage to get a new frame, a bigger frame, and this is going to be a little bit neater of a. But I am aware that you do have to have it symmetrical, and I do have imperfections, but it still works. I mean, the magnetic field, though, to be honest, I think we were having trouble getting the neodymium sphere to spin at that lower power setting. Just because maybe there are imperfections in the field geometry.
So you got a whole bunch of spin and coils in your design also.
I'm sorry, you said what? You cut out.
You have a lot of spin and coils in your design also.
Yes. So there's we have 24 wires twisted in a multifilar bundle.
And then you said you had some magnets spinning.
No, I had a neodymium sphere that was spinning in the center. With the older stereo amp receiver that was more powerful, we were able to get it to spin. But with the new one, we were having trouble getting it to spin.
Did you have greater effect when you had it spinning?
When it was spinning, I did monitor the circuit, and it did generate a little bit of voltage. So, I did notice a little bit of a spike on the output, but I really wasn't paying attention to that. What I was trying to do with the neodymium sphere was trying to get it to synchronize. And you know how like you see like Jack Scholes or Daniel Nunez take the neodymium sphere and synchronize it with the Rodin coils field, and then they can take it outside of the donut and it'll still spin.
I've never seen that. I heard of that. I heard that was going on, but I never actually saw it. You know, I heard Rodin mention that once. I'm sorry, Marco.
Okay, so give me a second. I'm going to double check everything. I'll get it working. I did have it working earlier with the app on my phone. So I'm going to try it on the app on the phone real quick just to eliminate that variable. So you'll see the camera go out or freeze.
It's crazy. So much trouble with this thing, with that new receiver he's got.
So you froze, Ben.
Sometimes things get glitchy.
Oh,
My laptop's
Okay,
been
so-
glitchy all night.
it's working with the the tone generator. Hold on, let me see if the XCam will work. So it is working. Okay, so and that's at 800. You can't see it on the phone, but I'm gonna switch to the laptop and show you in a second. So I know it does work. It's just something to do with this. Maybe the connection on the laptop wasn't solid. So give me a second.
Those 1/8-inch cables are horrible for
Very
transmitting.
temperamental.
Yeah, they don't like. Let's. You get them as short as you can get. As shorter the cable, the better, and the more money you spend on it, the better, because you want thick copper on those 1/8-inch audio. Anything to do with audio, you want a lot more copper. or conductor because it's low power signal.
Oh, yeah. It's just the connector needed to be pushed in a little bit. I think it has a little like corrosion or something on the inside, like making
they all
it tough
do that.
to.
You gotta wiggle it, something like that. They all do that.
Yeah. But give me a second. I'm going to turn the camera back on, and we'll demonstrate this. This is really cool. This is like the coolest thing because it's so easy to do.
Ben, when it comes to a $5 cable and a $20 cable, it's probably the one-time purchase, or at least the $20 cable will last you a few years. The $5 cable will last you a few months.
Yeah.
Pick your poison.
Huh.
I mean, I got buckets full of old cables. I spent plenty of money on audio cables. I don't use them anymore, even the good ones, because they're gone now. They don't carry a signal that good. You can't record with them. You can't make recordings. It was crackle or whatever, Not enough signal getting through.
Even old new ones?
Yeah, like even the expensive ones that I bought that are old that went bad. That's it. Forget it. It's garbage. Just keep it as a
Like
rope.
I have so many of those from so many different devices throughout, like, let's say
You
20
have to
years.
cut the ends off and restart our new terminals. The wire from one end to the other is probably still good, but the terminals are gone.
Mm.
Oh,
Do they
it's
get
just-
oxidized or is it
No, just bending and turning, and every time you
Okay.
plug it in and unplug it, you're bending
No.
the wire.
I've got brand new ones like that never been used,
Inside those cables, it's not thick wire. It's just very thin hair thickness wire. It's easy to break those wires. It's like
Oh, did it go
they
out?
do
Oh,
that
I'm
for
sorry,
like
guys.
the
I
audio
didn't
signal.
realize
I
it
think
went
the high frequency, the highs, they transmit through there like that. I guess maybe I'm wrong. I don't know, something like that. But at the same token, it's great for audio, but it's very,
There we go.
they don't last long because the wire's so thin.
All right, can you see this?
And yeah, it corrodes too.
Yep. We can
I have it at 60 hertz. It's on a very low power setting, by the way. The fan is started. It's not spinning fast, but it's spinning. The lights are dim, but they're on. But nothing on the output, right? Nothing on the rodent coil. That's on the left channel, which is not connected to the reference circuit. So obviously we're getting some kind of loss. I don't have the multimeters hooked up yet, but obviously there's some kind of loss. And then I switch it to, let's say, 800 hertz.
You speed up your frequency, your voltage should drop more.
You said what?
If you speed up your frequency, your voltage drop should be greater on your source. Whatever voltage you're feeding, you're going to have a drop on that voltage. It's going to drop.
Now the thing is not working. Hold on one second.
It's probably camera shy.
It has
It's
something
that
to do
audio
with the
cable.
tone generator, like that. Like he was saying, the cable, the tone generator. Or cable.
How long is the cable? If it's over 3 feet, it's probably no good. Those 6-foot cables are the worst. I don't even buy them anymore. If I get a cable, it's 3 feet if I can do it. If I can, do it. 6 foot is, you need it sometimes, but yeah. The shorter the cable, the better.
There's different qualities of cable. I sort of pay attention to some of the cables I get in there.
Yeah, it's the cable. It's like just okay. The cable. It's just not. I had to push it in a little bit more, and I don't want to break it.
When I buy those cheap ones, the
Okay.
1/8 inchers, I get like 3 of them or 4 of them at a time. Just because
Okay, so
I know they're going to go back.
as you can see, the lights came on a little bit on the reference circuit, right? They're a little dim. No fan because there's not a lot of current. This is spinning pretty nicely. And the lights are a little bit brighter. Not fully bright, but a little bit brighter. And this is at 800 hertz. We switch it back to 60 and it'll flip. So now what do we see? The fan is spinning now. The lights are a little bit brighter. Not, you can't really notice it that much, but a little bit. Fan is off on this side. No lights. I didn't adjust the gain at all. All I did was switch the tone.
I'm willing to bet you, Ben, that the fan that started spinning at 60 hertz is closer to the source than the fan that spins at a higher frequency. In other words, in your circuit, it's closer to the source power, the fan that spins at 60 hertz.
So they're both at 60. Well, they're both getting 60 hertz.
Didn't
So
you say the other fan was spinning at 800 hertz, and the 60 hertz it flips to the other fan?
yes.
So that's what I'm saying. I'm saying the fan that only runs at 60 hertz is closer to the source power than the fan that only runs at 800 hertz.
Well, I mean,
they flip, right? They flip.
closer
One
to the
runs, the
source
other
power.
doesn't.
I mean, it doesn't matter because I can change these wires back here. I can flip the left to right. It doesn't matter. It'll have the same effect.
How it's wired is the fan that spins at 60 hertz closer to the power supply on the circuit?
I'm not sure. I don't know how to answer that question, to be honest. But all I know how to answer. All I know what to tell you is I can switch the wires to left and right, and it has the same effect.
No, okay. As you're coming in one way and then you switch it, you come in the other way.
So
That's what
I don't know if that answers your question, but
sort of.
But yeah, I can switch the wires. It doesn't matter. It's not something to do with the circuitry of the stereo amp. I have this big one that did the same
thing.
thing.
It flipped when you change the frequency, not when you switch the wires.
You said what?
I thought you were changing from 60 hertz to 800 hertz, and that's how it flips.
Yeah, so 60 hertz, you'll see the input, it gets a little bit more power than the output, like a standard circuit, right?
So
But
when you switch the wire, it flips, not when you switch the frequency. The two fans.
No, when I switch the frequency from 60 hertz to 800 hertz.
Then the two fans flip. One runs and the other stops.
Yes.
And what I'm saying is the one that starts running at 60 hertz is connected to the source power in the circuitry. It's closer to the source power than the fan that runs at 800 hertz. That fan in the circuitry is further away from the source power. I'm willing to bet that.
Well, it's only connected through this, but Mike, it's connected to this speaker wire, right? And it's connected to the left channel, and there's only a left and a right, and I've switched it. I've switched to left and I've switched to right. So if it's about the position of the left channel, that doesn't make sense because I've done it in the right channel.
What you're doing, you're switching the channels and the frequency at the same time?
No. But I've tested. What I'm saying is I've tested the left in the opposite. I've tested the left and the right and the right and the left. Right now, the reference circuit is hooked up to the left channel, and then we have the coil hooked up to the right channel. But I've switched it. At one point I had the reference circuit hooked up to the right channel and vice versa. So it's not about what's going into the circuit right here of the stereo amp. It's something to do with the coil.
Yeah, the coil has different levels of resonant frequency. You could go into resonant frequency at 60 hertz, and then when you step it up to 800 hertz, it could go into resonance again. So I made a device originally designed by Norman Wu-Tan. It was actually seized at the U.S. Patent Office in 1996. So I replicated his device. So when I hit about, I believe it was 60 hertz. The transformer that I was using was actually a doorbell transformer. Went into resonance. I was able to light up about 30 watts of LED bulbs. And then when I start going up on the signal generator, same input, same everything. As far as power levels, it was all the same. But the second I changed the frequency, the lights would go out. And as soon as I hit about, we're right around the 800 mark, like you. it would go back into resonant frequency and the lights would come back on again. So coils have multiple levels of resonant frequency, not just one. This depends on the hertz level, voltage, geometry of the coil that you're using. I think all that plays into into factor, right?
Well, both those fans are
So
the same coils, though. One
no,
runs,
I'm
the other
talking
stops.
about no, I'm talking about the actual rodent coil itself.
Yeah, but he's got two
They can,
fans in there. They're both the same fan.
that's irrelevant, Mike. I'm talking about the coil. If the coil goes into resonant frequency, it can go into resonant frequency at multiple different hertz levels, not just one. So
I
that's what I
switched it
think.
to a square wave. It seems to work a little bit better with the square versus
Also,
sine. Sorry, I didn't mean to interrupt.
the type of wave you're doing. I also found square wave was more effective than pure sine wave.
Yeah. Yeah, sorry, I didn't mean to
So
interrupt.
Higher
I just
frequency
had
goes
to.
further in the circuitry than the low frequency.
It's like taking your Tesla coil and running radio frequency to it, and it'll resonate in certain areas. So there's like 5 or 6 you can get in an average Tesla coil fairly easy when you do testing on it with your oscilloscope.
exactly, yes, yep.
Well, as I was saying, I think high frequency goes further in the circuit than low frequency. It travels further.
Well, yeah, because he's reducing the amps, so it goes through the circuit faster, and it can create a resonance in there, which amplifies his magnetic field to get the other side to run.
Yep. Yep. Exactly. Well, guys, we've gone over 2 hours. I'm pretty tired. I'm sure a lot of us are pretty tired.
Yeah.
It was a great show again. Yeah, it was been a busy week. A lot of podcasting going on this week with everybody. So yeah, I'd like to thank all our viewers that are logged into us tonight. Live chat was running really well tonight. So thanks to all our guys in the live chat. And we go live again next Friday night at 9 o'clock Eastern. And I'd like to thank Nathan, Ben, Philip, Mike, Justin, everybody. We'll see everybody next week and hope everybody has a great week and happy experimenting. And we'll see everybody soon.
See you guys.
Thanks, Mike. Happy
Right on.
Friday.
Thank you very much. Have a good night.
Yep.
Yeah.
Thanks,
Mark.
guys.
Thank you, Mike.
Take care.
Thank
Bye,
you.
everybody.
Bye.
Bye.
Well, I hope everybody had fun. Thank you for joining in on the stream tonight. Sorry about the technical issues with the 0-point energy generator. These things do happen when we're working live, but thanks for bearing with us. We did eventually figure it out. It was the cable, and the cable just has a little bit of corrosion on the inside, and it makes it a little tough to plug in all the way. And I didn't want to be too rough with my new stereo amp because I blew the last one. So thanks again for tuning in. And don't forget that we do have our rodent coil workshop this Sunday. So 9 a.m. Eastern Standard Time will get started. And we will go through the process from start to finish on how to build your spool, build your multi-filer wire, and how to wind your coil, how to configure the coil properly, how to hook it up to a stereo amp receiver like I have. And we're going to do everything on Sunday, and I hope you make it to that live stream. It's going to be an all-day event. It's going to be awesome, and I really appreciate all the support, guys. I got to get to bed. Peace.
Remember, if you like my content, please consider subscribing and hitting the like button on my videos. Comments and any form of engagement dramatically help us break through the YouTube algorithm. I also have a website with research on the Thunderstorm engine, plasmoid technology, and do-it-yourself guides for Malcolm Bendel's retrofit, courtesy of Jordan from Alchemical Science and the Martin Fleischmann Memorial Project. Check out my store for exclusive merchandise along with our forum, where you can post questions, share videos, and join in the community to help destigmatize all forms of forbidden knowledge. Don't forget to check out Jordan's channel Alchemical Science and Bob Greenier from the Martin Fleischmann Memorial Project YouTube channel. They're on the cutting edge of cold fusion technology. More updates on that coming soon. Stay tuned.